In this video, I'm going to take you through the nomenclature of alkanes. Alkanes are organic compounds and they form part of aliphatic compounds. The core of this video is for us to see how we can name alkanes and we solve some examples. The names of all alkanes end with ane, ane. So if you have alkanes, its name will end in what? ane. Whether or not the carbons are linked together end to end or in a ring, you still have it as ane. So in a ring you can see cycloalkanes, yes. So it's still ane. Alkanes with unbranched carbon chains are simply named by the number of carbons in the chain. So if you have an alkane with unbranched carbon chain, then we simply name it by the total number of carbons in the chain. Let's see the first four series of the alkanes. The first one, if you have an unbranched alkane with one carbon atom, then we call it methane. Methane. So one carbon atom. Now, all alkanes have the general formula CnH2n plus 2. You can see when you have an unbranched alkane with one carbon, you have C1H2n, H2 times 1 plus 2, making it 4. That's why we have methane to be CH4. The second on the list is what we call ethane, C2H6. So if your N is 2, you have 2 times 2 plus 2, that is 6. And that is giving us ethane. The third on the list is C3H8, and that is what we call propane. Then we have 4 C4H10, that is what butane. And this has 4 carbons in each chain. So it goes on to pentane, hexane in that manner. So as I said, all alkanes are named with the ending being ane, that is ane, and that is how we name alkanes. In drawing of hydrocarbons, in drawing of alkanes, we have what we call the condensed structure. Condensed structure, as well as we have what we call the skeletal structure. Skeletal structure. So the C2H6, the C3H8 is what we call the condensed structure. And the skeletal structure, we use just this to represent our alkanes or our hydrocarbons, where each point is a carbon C. It's a carbon C, 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 C. So let's see. Assuming we have C3H8, where we have 3 carbons, the open structure is C3H8. So you have C, 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 like this. Then the H, they are 8 in number. So here is H, here is H, here is H, here is H, then here is H, making 8 hydrogens. To draw the skeletal structure, since we have 3 C's, you are only going to have first carbon, second carbon, then third carbon. And this is simply the shorthand form for our propane. And that is what we call the skeletal structure of organic compounds. In order for us to name branch alkanes, we need to know what we call the alkyl groups. What's an alkyl group? Alkanes, as I said, are generally represented as CnH2n plus 2. An alkyl group is formed by removing one hydrogen from an alkane, and you are going to get CnH2n plus 1. That is what we call an alkyl group. If I have methane CH4 and I remove one hydrogen, I'll get CH3, and we call it methyl. The name is formed by removing the ANE from the methane and replace it with what? YL methyl, because it's alkyl. The other one was alkane, so methyl. If I have ethane C2H5, I will get C2H4, and that is what we call ethyl. Sorry, C2H6, I'll end up getting C2H5, and that is what we call ethyl. So these are alkyl groups. These are alkyl groups. So let's see. We have what we call the molecular formula, and we have what we call the condensed structure. Condensed. So assuming you have C2H6, these are the molecular formula. Molecularly C2, 2 carbons and 6 hydrogens. But condensed structure will say that you have CH3, CH3. This is because when you have the open structure C, you have 2 carbons. There will be one bond here, one hydrogen to make the carbon. Each carbon will have 4 branches. Then another hydrogen will come, another hydrogen will come. So this is the CH3 here, CH3 here. This is the open structure, this is the condensed structure formula. While this is the molecular. We can do same for butane, which is 4 carbons. So butane is C4H10. The condensed structure is CH3. You have CH2, which is 2, then CH3. You can see that we have 4 carbons. Each carbon will have a hydrogen. Each carbon will have a hydrogen to make 4 complete bonds, and the leftover bond will be between the carbon and the carbon. So you can see that we have 2 CH2 here, then we have CH3 at the ends, and this is what we call the open structure. Then we have the condensed structure, which we have opened. Now let's see how we can name our alkanes. So to name an alkanes, the first thing we do is you choose the longest, most substituted carbon chain containing a functional group. So it should be the longest chain, and once you have 2 or more long chains being equal in the number of carbons, you then consider the most substituted carbon, meaning that the carbon which has substituents, that branch is what will be taken as the longest chain. All this is done in order to reduce the number, that is the location of our substituents. So the locant number should be as lowest as possible. So we always choose the longest chain with the most substituted carbon or functional group. Now, a carbon bonded to a functional group must have the lowest possible carbon number. If you have a carbon bonded to a functional group, then that carbon should have the lowest possible carbon number. So if you have a situation where you have a functional group, let's say you have this structure like this, you have your functional group, let's say, let me make it this way longer. Then let's say you have your functional group here, COOH. This is a carbon containing the functional group. If you want to start naming, you can either start naming carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8, carbon 9. But the rule is saying that we should take the lowest possible carbon which has the functional group. So you can start from here, carbon 1, carbon 2, carbon 3, carbon 4. And this is the lowest possible. So this is the fourth carbon instead of counting from this side. And that is how the rule goes. Now let's see. For the substituents, we have an organic substituent and we have inorganic substituents. Considering inorganic substituents such as chlorine, bromine, these inorganic substituents, which are usually or commonly used, we name it alphabetically. Alphabetically. That is a rule. It should be alphabetically. And once you are considering it in the alphabetical order, you should make sure that you assign the lowest number to it. So assuming you have something like this, you have your bromine, then you have your chlorine somewhere here. This is carbon 1, carbon 2, carbon 3. So 1, 2, 3, 4, 5, 6. Bromine is at carbon 5. If you want to name, you have 5 bromo. But bromine will come first before chlorine. So what you are going to do is, instead of counting it this way, you start 1, 2, 3, 4, 5, 6. So that bromine will take the least number possible because it is coming first. So that it becomes 2 bromo. This is another rule. So take note of how I'm taking you through the rules for naming. So let's see how we can name our compounds. So let's see. So considering the substituents once again, we are going to have series of examples for you to understand everything I am saying. So let's see. Let me start with my examples. And the first example I'm going to solve with you is this one. I have H, CH, H, 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 CH, H here, C, CH2, CH3. Then I have an H here, CH, then H, CH, then H, then this is H. To find the name of this alkane, we have to identify the longest carbon chain. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, and this is one chain. I can have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. This is another chain, right? So how are we going to name this? Since you have 1, 2, 3, 4, 5, 6, we have 1, 2, 3, 4, 5, 6. They are all chains of the same number of carbons. Which one do we take? And the rule was we should take the chain with the most substituted or with the most branching. And you can see that this is the chain we have here. So we have to take 1, 2, 3, 4, 5, 6, and that will be the chain we are supposed to do what? Take, right? Once you take this chain, you ask yourself, if this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, then this here becomes a what? A substituent. Here is CH2, CH3. But let's see something. You can see that if I take 1, 2, 3, 4, 5, 6, this becomes the same as I had if I had chosen 1, 2, 3, 4, 5, 6. In this scenario, you realize that whether you take this or you take this, it should give us the same thing. For that reason, let's choose 1, 2, 3, 4, 5, 6 since it's the same as choosing this. Now, this is where we find our substituents on this carbon. Are we supposed to start counting from this side or this side? The decision depends on where it will give us the lowest possible number. Starting from here, I'll get 1, 2, 3. Starting from here, I'll get 1, 2, 3, 4. So it's advisable for me to start from here and I have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, then carbon 6. My substituent is on the carbon 3. And the substituent is what? CH2CH3. That is C2H5. Ethyl. So you have 3 ethyl, right? Then I'll have 1, 2, 3, 4, 5, 6. That is what? Hexane. Since we are dealing with what? An alkane. And that is how we name it. Let's take another example. I have H3C, CH. I have here to be CH3, CH, CH3, going into CH2, CH3. We have to name this. What will be the longest chain? 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. So this is the longest chain I have. I have one substituent here, one substituent here. The first substituent should be the lowest possible number. Starting counting from here, I'll have 1, 2, then here 1, 2, 3. So meaning I have to take this side. So that I have 2, and they are all methyl. So it will be a dimethyl for the alkyl group. So 1, 2, right? Then this is 3. So 2, 3. Since they are the same methyl, if it was methyl and ethyl, you say 2 dash ethyl, 2 dash methyl. But here they are the same. So we say that 2, 3 dash dimethyl. 1, 2, 3, 4, 5. So pentane, right? That is a simple way to name this compound. Thank you for being with me in this video. Please, you like, you subscribe, then you share. Join me in my subsequent organic tutorials.